Hi guys, good morning or afternoon, or like Jose said, even good evening wherever you are. It's nice to see some of you. It looks like maybe I've seen a couple of you from the Reimagined Building Collective, which is awesome. Hopefully some more of you kind of join in because the water is warm over there. And then I'm also really hoping, I'm very excited for Friday's kind of web conference about the biomaterials. And I hope some of you are also kind of keen to join that one. And today we have an awesome presentation about carbon, but it's a nice little marriage between the two. And maybe after Friday, you'll kind of think so. I'm ecstatic that we're talking about carbon. I love talking about carbon. So I'm excited for Elisabeth's presentation. And with that, I will hand it off to Jose to introduce her.
Hey, thank you, Sarah. And yeah, good to see everyone. A little bit about Elisabeth. She's an experienced leader in policy development and community resiliency. Her dedication to advancing low carbon construction practices has been the driving force behind the creation of CarbonWise. CarbonWise aims to serve as a bridge between the realities of on-the-ground construction in the industry and the imperative actions needed to meet our climate targets. In 2022, Elisabeth spearheaded the development of the inaugural Body Emissions Guide for local governments, offering a comprehensive list of strategies tailored for municipalities in British Columbia to mitigate their embodied emissions. Furthermore, she has collaborated closely with over 20 local governments, the Step Code Council, and the province of British Columbia in the implementation of the British Columbia Energy Step Code and Zero Carbon Step Code, granting her an in-depth understanding of the intricate challenges inherent to our industry. So with that, I will cede the floor to Elisabeth. Take it away.
Thank you so much for the great introduction, for the team to put this together. I was just looking back and we did a presentation back, I think it was in January, and now in December, it feels like closing up the year on a high. So I'm very excited to be here. And before we dive into today's session, we'd like to take a moment to acknowledge that I am privileged to reside, work, and play on the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh nations in today's city of Vancouver, BC, Canada. And I'm very excited about talking about embodied carbon. This has been a passion of mine since 2020, and really the reason behind the creation of CarbonWise. So CarbonWise is an energy and carbon consulting firm based in Vancouver and Nanaimo in BC. Our mission is pretty simple. It's accelerating low carbon construction, but that means a lot of different things. So our focus areas include energy modeling, net zero energy modeling, blower door testing, and whole building lifecycle assessments to balance the operational and embodied emissions. We have experience with new builds, retrofits, and collaborations with local governments. And we are the two-time winner of the BC Embodied Carbon Awards in 2023-2024 with one project that I will also showcase towards the end of the presentation. So let's have a look at the agenda for today. We'll get started with understanding greenhouse gas emissions in construction. Like the topic of this session today is 101. So understanding, what is the difference between operational and embodied carbon, and a bit more generally, greenhouse gas emissions in construction. And then a deep dive on reducing embodied emissions and why it is important that we address those emissions right now. And then we'll end with LCAs in practice, some strategies, and hopefully easy, actionable takeaways for you to take into your practices. So as you probably know, or have heard before, the construction industry accounts for about 40% of global greenhouse gas emissions. So you probably have seen a pie like this before, or in some shape or form, and roughly 28% of those emissions come from operational emissions, so energy used in buildings, and 11% from embodied emissions, so that is materials, construction, and end-of-life process. Materials like concrete, steel, and insulation are major contributors to embodied emissions. And really, without intervention right now, emissions in the construction sector could double by 2060. So it is important we are at the good time for reducing both operational and embodied emissions. And it's very critical that we do this now if we are to meet our global climate targets. So, like I was saying, there are different types of emissions throughout the life cycle of a building. The top 3 sources of operational emissions are fossil fuel space heating, domestic hot water heating, and cooking appliances. And that's basically during the building's operation, when fossil fuels are burned to heat the home, generate hot water, and cook. And those are called operational emissions. And that's where a lot of the energy efficiency policies have been focused over the past few years. But another type of emissions that is often forgotten is embodied emissions. And they are associated with all the manufacturing, transportation, decommissioning of materials. And the top 3 sources of embodied emissions are concrete, steel, and petroleum-based insulation. We'll get a little bit more into this, but as a kind of a rule of thumb, any material that takes a lot of energy and efforts to make will have high embodied emissions. So operational emissions are ongoing and can be reduced through energy efficient design and technology. But the important thing to know is that embodied emissions, most of embodied emissions are emitted even before the owners move in and at the time of construction. And so those can be addressed through design strategies that we'll get into, sustainable material choices, and circular practices. We'll talk a bit more about that. First, I like to always clarify the terminology embodied carbon, embodied emissions. I used them interchangeably, but I prefer embodied emissions because carbon could be a bit misleading. We are not only talking about carbon, we are talking about different greenhouse gas emissions. And the term embodied is really embodied in the processes. So embodied emissions are the greenhouse gas emissions associated with the materials and processes involved in the construction of a building or infrastructures throughout its entire life cycle. So that includes emissions from extracting raw materials, manufacturing building products, transporting those materials to sites, the construction process itself, and then also the end of life, deconstruction and recycling of these materials. So what happens at the end of life of a building? Is the home getting demolished? Does everything just end up in the landfill? Does it get recycled, reused? And all of those streams have different emissions associated with them. So you can see here that operational emissions in blue represent only one stage of the life cycle emissions. So historically, operational emissions have been really high. And that's why a lot of the policies have been focused on reducing operational emissions. And I think it makes sense from a term that operational are more visible, if we can say that like this, because every time you'll turn on your furnace, you'll emit greenhouse gas emissions, for example. But it's a bit less intuitive with embodied emissions because a lot of the emissions associated with the materials happen, before or during construction. So once the homeowners have moved in, they don't really realize what went into building their house. So it's a bit harder to grasp for homeowners and to understand, what are the choices that we can make that could have a better impact. This is another graph to show the emissions quantified over time. So like I was saying, the upfront embodied emissions or embodied carbon are most of the entire life cycle embodied emissions. So when it's about 70 to 80%. So at completion of the house, then a lot of greenhouse gas emissions will have already been emitted. And then comes in the operational emissions in blue, but that are now very low, especially in passive houses where we have reduced this energy demand and we are electrifying and we are using very little energy, and this energy is clean. So operational emissions end up being very, very low. which makes then embodied carbon a lot higher and a bigger portion of the pie. So addressing embodied emissions is essential right now when we want to achieve overall carbon reductions in the construction sector, because they have often been overlooked, but now we are getting a lot better at quantifying them through life cycle assessments. And I always say we can't reduce what we can't measure. So now that we get a better understanding of what they are, how to reduce them, and we can quantify them, then it becomes easier to make the right decisions. And that's another way to visualize the entire life cycle of a building with upfront embodied carbon, as you can see on the left side. So the A, production and construction stage, so that's upfront embodied carbon, which is usually the highest. And then there's the B, use stage on the top right, and then the end of life C stage, the bottom right. And I put in some key terms here. When we think about embodied emissions, we also want to think about circular economy. It's linked, same as resiliency, in my opinion. We want to just build better, and that means a lot of different things, but including the words circular economy, material efficiency, waste reduction in the efforts towards reducing embodied carbon is important. A lot of homes that we are seeing, for example, right now in Vancouver are being demolished for making space for bigger multi-units. And that's, for example, a good example of the end of life stage, where we can look at more circular principles and reuse those homes either as is, by just relocating the home, or deconstructing the home, taking the home apart, reusing some of those materials, and make sure that we reuse them in the next build, or we exchange them on the secondhand market. So there are all of those actions reduce embodied emissions, because we reduce the need for new extraction of raw materials. So I like to link the two in terms of emissions and circularity, because they really go hand in hand. And overall, it's about really using less when we talk about embodied carbon. So why embodied emissions matter? I often say that it's a big elephant in the room. So first, because it becomes an increasing portion of emissions. So as I was saying, operational emissions are going down globally, thanks to energy code, low emission grids, and electrification, and the passive house concepts. We make our homes just much more efficient now than we used to 50 years ago. So operational emissions are going down. But that can mean, or could mean, that we are increasing our embodied emissions, because we are building more infrastructure and materials, such as a new dam. If we are going to electrify all our buildings, we might need more. In BC, this is the case. Electricity comes from hydro. So we might need more infrastructure, more materials, and that might mean, and it's not necessarily the case, but that might mean high carbon materials. And we're going to get a little bit more into that. And you'll probably learn a lot more about bio-based materials on Friday as well. So those are high carbon materials, often used in high performance homes now, but they don't have to. And then increased use of refrigerants. This is a topic that is becoming more and more front and center with the use of heat pumps. We are far from being an expert on HVAC, but we do use more refrigerants, and there is a risk of leakage, and I'll get a little bit more into that. And the reason behind founding CarbonWise and the work that we do is that at some point I realized, well, we are building those high performance homes, but are we doing the right thing? And if we don't pay attention to the materials, we are actually doing the wrong things. So it becomes important for us in our practice and the industry in general to find the right balance between operational emissions and embodied emissions. So sometimes some materials make sense to add because they will reduce the operational emissions, but sometimes maybe it doesn't make sense. And that we can only know when we do a full life cycle assessment. So it's important to know that an energy efficient building does not equal a high embodied carbon building if low carbon material choices are taken into consideration early in the design. Thicker walls might mean increased embodied emissions. And it's, again, when we talk about this balance, that's where it comes in, because we do want to improve energy efficiency by increasing insulation levels and reducing heat loss in buildings. But that could significantly raise the embodied carbon if we use high carbon materials. Thicker walls also mean more insulation, framing, cladding materials, and they have a higher embodied carbon footprint from extraction, manufacturing, and transportation. So more of the high carbon materials is counterproductive, but more of the low carbon materials is a good thing. So that's why we need to explore low carbon materials and optimize design strategies to minimize embodied emissions while also maintaining energy performance. Because some insulation materials with a higher R value provide, yes, better thermal performance and improve the building's energy efficiency by reducing the heat transfer, but they often have a high carbon footprint due to energy intensive processes and just being manufactured from petrochemicals. So it's important to look, and here on this graph, we see some of the best insulating materials have a higher embodied carbon. And if you're going to attend some of the webinars coming up, you'll meet Chris Magwood, who from Builders for Climate Action, who created this graph. And I like this graph because it really shows, you know, all of the range of options that we have. And even if we don't go to straw bale, which, you know, on the first project might be a bit challenging, how do we make that happen, you know? There is a range of materials between the best of the best and the worst of the worst. And I always say it's about, you know, getting rid of the worst now and little by little moving on to the best options. So you have some examples here. And then, yes, increased use of heat pumps might mean increased embodied carbon from refrigerant leakage. So refrigerants used in HVAC systems and heat pumps are typically high global warming potential, GWP, such as HFCs. And so the global warming potential of these refrigerants can range from 100 to over 2,000 times that of CO2 over a 100-year period. So when refrigerant leakage occurs during installation, operation, and decommissioning, the greenhouse gases can be released directly into the atmosphere. And for HVAC systems, refrigerant leakage is often the largest single source of embodied emissions. So even a minor leak can negate operational carbon savings as achieved through energy efficiency systems. So to mitigate this, it's important to start thinking about in the design and material choices, so opting for systems using low GWP refrigerants like R32 or natural refrigerants as like CO2. I'm curious about the group's experience, actually. We can get into this in the questions about having used some of those low GWP refrigerants, if anybody has first-hand experience. And also at the end of life, managing the equipment. So doing a proper recovery, recycling, and destruction of refrigerants during the decommissioning phase. So those are important things to consider. Again, this is, you know, we are only getting started on embodied emissions of mechanical systems, but refrigerants, if there is one thing that we need to address quickly, is definitely refrigerants. Why are we talking a lot more about embodied emissions and why it is important also to address them now is that they have often been overlooked, but that doesn't mean that they don't exist. So like I was saying, it's a bit harder to visualize, where those emissions are coming from and what are the things that we can do to reduce embodied emissions. But it's also hard to keep someone accountable for them because there is no territorial boundaries. So when we are building a house in Vancouver, but the materials come from China, is China responsible for those emissions, or are we responsible for those emissions because we are ordering those materials from there? And China having a lot of coal, their materials will definitely have a higher embodied carbon, plus the transportation, etc. So it's hard to keep someone accountable for those emissions. And also we live in a world where everything is so available, right? We go to Home Depot and we can grab whatever material and it's right there on the shelf. We don't really think about where that is coming from, what's the process behind it. And this has made our life much easier because we can get everything we want right away, but we don't always think about where that's coming from and all of the process behind it. So it has also been overlooked because they were hard to calculate. So for all of those reasons, it's very hard to say, well, this product, tracing back the supply chain, understanding where it's coming from, what is the process, and if this is not greenwashing, understanding like what is a good material versus what is a high carbon material. And we have made a lot of improvements over the years now, looking at lifecycle assessments, lots of different software available to have better and more accurate data. So this has improved a lot over the past few years. And we are getting at a point now that we know there are benchmarks. We know what is on a scale a good or a bad building in terms of embodied emissions. And we are at a stage where we know how to calculate and reduce those emissions now. Another reason why we need to address embodied emissions is that we are building a lot, and we will be building a lot more in the future. So we know the demand for new homes is skyrocketing everywhere, and while building more housing is critical, it also comes with a serious challenge, the risk of massively increasing embodied emissions. So if we don't act, the emissions from the materials alone in future construction could wipe out all of the progress that we've made in reducing operational carbon through energy efficiency. So, but there is hope, is that we can take action now by making smarter choices, like using low carbon materials, mass timber, recycled steel, low carbon concrete, or not using concrete at all. And we can design buildings that use fewer materials overall and reuse materials instead of always going for new ones. The point is, if we think ahead and shift how we build, we can meet the growing demand for housing and also keep our climate goals on track. So the future of housing can be sustainable, but only if we plan for it. And so what does that look like in practice? So LCAs are to embodied emissions what energy modeling is to energy efficiency. So that's how we quantify embodied emissions. And there are many reasons to have an LCA done on one of your projects. Some of them are those international standards. It could be regulated in some of the European countries. Example of France. So I'm originally from France, and I keep an eye on what's happening there. And now LCAs are required for all new buildings. I think it was since 2023. And that's just part of the national code. So it is a requirement. In Canada, it is not yet a requirement. It is becoming required for larger buildings in the city of Vancouver. And with now a reduction target that's coming in the spring. But there are also some voluntary standards that include embodied carbon credits to promote holistic approach to sustainability. You might have worked with LEED, so a widely recognized green building certification that includes credits for reducing embodied emissions through the materials and resources category. So points are awarded for using low carbon materials, recycled content, and also just the fact of conducting the life cycle assessment. So we are currently working on a living building zero carbon certification on the house that I'm going to present in a few slides. And in this, again, we are looking at operational and embodied and finding the right balance between the two. There's lots of standards, and but the most like the ones that we use the most, at least us in Canada, are the ones circling here. And so where to start with an LCA, that can be a bit of an overwhelming process, but I thought I'd clarify some of the terminology, the cradle to grave versus cradle to gate. So cradle to gate focus on the environmental impacts of the product from the extraction of raw materials through its manufacture and delivery. So essentially stopping at the point where it leaves the factory gate. And this type of analysis is valuable for manufacturers and designers aiming to understand the embodied impacts of production without considering the product's use or disposal, which is just by the fact of being, later in the process, a lot harder to define as well. Cradle to grave, on the other hand, extends the assessment all the way through the product's entire life cycle. So including its use phase and final disposal, it offers a more complete picture of the long-term environmental impacts, accounting not for just how the products are made, but how they are used and what happens when they are no longer needed. So like I was saying, the upfront embodied carbon, the A stage, is where most of the embodied emissions happen. So that's why some of the focus sometimes on some of the tools have been on those, is that if you want to have a quick high impact, just focus on that. And that's a very valid point, but we can't forget also what happens at the end of life, which can save, again, full loop, full circle. The way we recover materials at the end of life can also lead to less upfront on the next building. So important to keep looking at this with a circle. Some strategies for reducing embodied emissions, and I like to say costs as well. I realize they should be organized in the other order, but let's start at the bottom. The number one is thinking building nothing. So I just said we have housing mandates and we need to be building more housing. So when I say building nothing, I don't mean nothing, but looking at whether we need to be building that new building at all. So can we relocate the home that is there? Can we make use of what is already there, add on top? We've seen a lot of these. An example here in the city of Vancouver was the Amazon office just built on top of the old Canada Post building. So they maintained and kept the structure. And that meant that just less new material, less everything. So that's repurposing as well, retrofitting instead of building new. This falls into this category, building less. This is when we start talking about sufficiency. So can we build smaller? Do we already need to be living in like 5,000 square feet homes with 5 bathrooms? Those are things that we need to start thinking about sufficiency. How much is enough? Can we also share buildings for different uses? So can we make them flexible for a growing family, but then understanding maybe the kids are going to move out? So some walls can be moved or taken down so that we can make a bigger office space, or just being flexible and smart about how we use the space. Next one up, building clever. This is where terms like design for disassembly come in. So making sure that what we have to build and what we build is done in a smart way for us to be able to recover some of those materials and avoid making new materials from scratch. So can we also use local low carbon materials versus materials that are coming from the end of the world? So for example, in BC, we have a strong forestry industry. So can we use some of the waste coming from it to make construction materials? Yes, we can do that. So, and the last one here, building efficiently. So that's minimizing design loads, prefab, and minimizing waste. So again, let's be efficient in the way we design our buildings. So making most of the materials and space we have, and thinking about the use. I always put an example of millwork because I have a friend who works in millwork, and the amount of waste in millwork is just mind-blowing. And so reducing that waste, making sure we use software to reduce offcuts and make the most use of the materials that we have will mean that we won't be creating and extracting new materials. And so how do we make the right material choices, you ask? That's where environmental product declarations come in. So EPD, you might have heard the term EPD. They are basically, product EPDs are the equivalent of your food nutritional labels. So, you know, getting into the holiday season here, I'll try to find a seasonal example, but let's say a glass of eggnog will be that many kilocalories. Well, here for a cubic meter of concrete, it will be that many greenhouse gas emissions. And that's how EPDs are the base of the whole building life cycle assessments, because we look at, you know, a certain material, their emissions, and then we multiply by just the quantity of this material in the building. EPDs are extremely important because they are the most accurate data available for products, and they are third-party verified. They follow the ISO standards, so there are very strict rules about how EPDs are made, which means that we can rely on the information. They also allow for apples to apples comparisons. So between two concrete mixes, which one has the lowest carbon? Well, we're going to be looking at a cubic meter of this one versus a cubic meter of that one. So we know, understanding that the process has been verified and is following the same standards, we know that, you know, we are comparing apples to apples. And they can be product or plant specific. So meaning for a product, it could be, so it goes everything that goes into making this product versus a plant specific, which is the location, the specific location that this product is made out of. So there are different variations on the level of, you know, how far we want to go. And I saw Innotech Windows is on this call, and we looked at their EPD recently, and that's one thing for Windows that we look at is, well, those windows are made for a certain dimension in a certain plant, so we will have an EPD for that, for those dimensions, and we can talk about this maybe during the Q&A too. And so where to start in practice? Whole building LCAs help architects, builders, developers make informed decisions by providing a comprehensive understanding of how different materials and design choices can affect a building's carbon footprint. And so by integrating the LCA into the design process, projects can really achieve significant reductions, but we start thinking, you know, ahead of time. Environmental product declarations are used to compare materials to materials and are the basis of LCAs. So the more EPDs we have, the better this is all going to get, and the more accurate all of our practice is going to be. And EPDs are really used on a product by product, could be used also on a product by product. So like I was saying, comparing two products, which one should we select? Well, this one has a lower carbon footprint, let's go with this one. So without EPDs, it makes it very hard, because that allows a lot of greenwashing, understanding like, yes, we have a low carbon material. Okay, what does that mean? You know, so for us, I always ask, the first question to ask is always ask, do you have an EPD? How do you prove that your material is indeed low carbon? And I like to say asking the right questions, because even though, you know, this is a lot and to take on, and not every client will be willing to do an LCA, pay for an LCA. Not everybody will have the resources to do an LCA, even just asking the right questions. So as industry professionals, we are we are there to also to ask manufacturers, well, do you have an EPD? If not, have you considered are some of your materials recycled? Do you have recycled content? Asking those questions, even though they might not have an EPD, or maybe the answers will be no. It actually, the more we keep asking questions, the more they will think, oh, we need that. If everybody keeps asking for EPDs, then maybe we should be making an EPD. Maybe that's an advantage for us as a company to show that we are manufacturing low carbon materials, and that has value. So I always poke the questions everywhere I go. Some of the key materials to look for, if there were only 3, we would be looking at concrete. Concrete is the highest carbon material we use in single family homes, or in even multi-unit. The less we use concrete as of now, the better. And I'll get into this on the next slide, but right now there are some low carbon concrete alternatives. In BC, we have some of the lowest carbon concrete in Canada, but still concrete is a high carbon material. So thinking about ways to reduce the use of concrete is always number one. Concrete can be reused on site, and I'll show you that with an example of a house we're working on. It can also be crushed for other uses. So always thinking concrete, number one, what can we do to minimize its use, and just reuse as much as possible. Then metals, steel, and aluminum can be recycled indefinitely. So always thinking, do we want, and that's a great question maybe for the Q&A, but conversations about metal roofs versus shingles, and like how do we what is best, because a metal roof will have higher upfront carbon, but it eventually maybe lasts longer and doesn't need to be replaced. So how does that play into the equation? Again, lots of questions. There is no right or wrong answers in terms of metal versus asphalt, but there is use case, carbon comes into the equation, and we've had this conversation with multiple clients already, and I'm happy to chat more about that later too. And last but not least, the wood. Lumber can be reused. Right now in BC, we are not allowed to use lumber from deconstructed houses for structural elements, but there are still a lot of uses for reclaimed lumber. And that might vary from a state to another in the US as well, what is allowed versus what is not allowed. But reclaimed lumber can be used for flooring, beams, fences, a lot of other things. And again, always thinking, can we use less material? Can we use less raw materials, and reuse as much from what we currently have? Here are some strategies for using less concrete in practice. We see for basement, and that is from the City of Nelson low carbon materials guidance strategies, which I recommend. I will share the link afterwards. They have a lot of great resources on in practice. What does that mean? Here are some solutions. Again, Peer Foundation, we have a couple projects right now working with Peer Foundation. This is great, just reduces the need for concrete. We want to move towards the concrete free slab, but again, lots of challenges sometimes around moisture, and happy to chat about this afterwards as well on what if some of you have first-hand experience with that. And I'll be quick because I'm noticing we are moving with the time here. Some low carbon insulation materials. Wood fiber, cellulose, and straw. I am a big fan of wood fiber. I think wood fiber is the future. Lots of options to use wood fiber to replace existing EPS or XPS, which is a one-on-one replacement, makes it super easy to swap. Cellulose could be used in a lot of cases as well. In prefab walls, we see a lot of those right now. We have a lot of projects using cellulose. And actually just the cellulose is going into our Phoenix House project that I'm going to talk about in the next couple of weeks. So this is materials that are available now. Straw, you'll probably talk a lot more about straw on Friday, but most likely used in prefab just because it is then built in a controlled environment versus on site. But again, something that we will see more and more in the future. And I will just end the presentation with an example of the Phoenix House, which is a project we are currently working on. That is the project for which we won the Embodied Carbon Award earlier this year. And so not only it had very low operational emissions, we also then looked at, that was an all-electric building, very low operational emissions. For those in BC, they meet step 5 and zero carbon step code. We reused the concrete slab, and in this case, that was 16 tons of CO2 equivalent that were saved. So when we say using less concrete, that's the first conversation I had with the homeowners, and we had an integrated design process very early on, spent 3 hours with the homeowners, discussing their vision for this build. They had lost their home to a fire, and they are rebuilding their home, and they really wanted to make it long lasting for multi-generational home for their family with a suite to have multiple family members. So we were thinking about people who really wanted to do the right thing, and right away we talked about, well, there is your home, even though it burned, and some of the wood can't be recovered because of that. Some wood still got recovered and is being reused for fences and forming and a lot of different things that are non-structural. But then we start, well, you have a concrete slab, so why don't we just reuse this concrete slab? It's there, it's in good condition, it has been approved by structural, and we ended up just pouring a little bit of low carbon concrete on the side to just expand the footprint a little bit. And that's still just this decision of reusing the concrete slab saved 16 tons of CO2 equivalent. So that is huge, and also saved about $200+ $1,000. So when we think about, reducing embodied carbon, a lot of people always think, well, this is another thing we need to do, it's an extra cost. It's actually a lot of cost savings. We have to make use of what we already have, which means we don't need to buy new. So just the cost from not having to excavate, clean the side, get rid of the concrete, all of that was taken into account here. Here we used also hemp insulation in the walls. This is actually coming in also, I think next week, I have to go check it out. And cellulose in the exterior walls, and used of reclaimed siding. So again, a really cool story about we knew for the embodied carbon that we wanted to go low reclaimed siding, but how do we find reclaimed siding and what are our options? So long conversations, and the builder found some wood that was salvaged from a wildfire in BC, and that is going to be used for the exterior. So a lot of good stories, and it's about finding ways to reach those goals and reaching and finding those materials, but it is absolutely doable. And the last thing I want to mention here is the windows selection. So we in the very first LCA we looked at double versus triple, a conversation we keep having with clients, and triple glazed windows often have a higher embodied carbon just because of that extra pane of glass. And what are the benefits in terms of operational emissions? And in this case, when we ran the energy model, this home could still achieve the highest performance with double glazed windows. So then the conversation went around, well, can we use double glazed windows? The homeowners are all on board. And we started thinking double glazed versus triple, but they're also thinking about the size of the windows, because when we took into consideration the fact that we're going to be using hemp, cellulose, reclaimed siding, the top 1 emitter for this home ended up, and we have barely any concrete, so the top 1 emitter for this house ended up being windows. So when we brought it up and said, well, are you willing to reduce the size of your windows, go maybe double glazed, or, you know, remove some of your windows. This is never a fun conversation to have with a homeowner, but they were actually open to it. And they said, well, if it helps our carbon, then why don't we have a look? And the architect got back to us with looking at, you know, reducing some window sizes, moving a couple different windows around to make sure they still have plenty of daylight in the house. And that ended up reducing embodied emissions. So we also had a conversation with the window manufacturer and did a comparison between different window manufacturers on windows, and ended up to settle on a mix of double and triple, mostly triple on the front of the house for noise and safety, well, mostly for noise, and then having double glazed windows on the upper floor. So that's what we decided on. I could speak about this project for a long time, so I'll keep on moving. Just to put things in perspective, the concrete slab of this specific house, Phoenix House, 16 tons of CO2 equivalent, is equal to 11 round trips Vancouver, New York. So when we put things in perspective, this is, you know, the impact of one project and what that can have. And I like to put those comparisons because, well, we all like our beer, right? So let's keep drinking beer and let's reduce embodied emissions in our buildings. And finally, this project overall was, those are the numbers on the right for the data nerd like me, and we are below 50% compared to international benchmarks. So one thing in conclusion about this project is that, yes, we put our heads together and it was an integrated design process. That is the success of this project. The homeowners were super keen, super on board. But what I want to say is that this is achievable today with the materials that we have today, with the techniques we have today, and it's about, you know, being creative and having those discussions early on in the design phase, versus too late when it's already under construction. So everybody was on board. This project is being filmed for a documentary. We will be sharing a lot around, you know, the decisions, why those materials versus others, the whole construction process. The homeowners are taking this initiative to the film and the documentary themselves, and we have support and sponsors. And this has become a next level project for us, but really in terms of carbon, this is what we can and maybe should all be doing now. So just want to say that this is very doable. We are doing it, and you'll hear a lot more about this on the Phoenix House website and documentary. And that is all for me today. Thank you so much. I feel like I haven't been checking the chat at all. I see a lot of notifications. So I'll let you take the lead, Zach, into the next phase.
That was an awesome presentation, Elisabeth. Thank you so much. And yeah, the chat, we're discussing a little bit in the chat what you've been talking about. I just want to say really quick that it's interesting, and like, thank you for actually addressing and pointing out the fact that the embodied carbon emissions actually might kind of increase if we're not kind of careful and intentional about that. I feel like, you know, and there's quite a few discussions about carbon these days, and it's great. I'm happy that we're talking about it, and we definitely kind of, you know, weigh the operational and embodied carbon, but we're not actually talking about the fact that there might be more material use. There might be, you know, you still have to account for the fact that things are going to be created and made in a manufacturing plant maybe, but the fact that there's actually going to be probably an increase if we're not actually really intentionally planning for that. So thank you. Just had to shout that out really quickly. You are correct. We have some great questions and some awesome thoughts that kind of went down in the chat. And before we get to those, I just want to turn it over to Zach to give a quick thank you to our sponsors today.
Yeah, thank you, Sarah and Elisabeth. Fantastic presentation. Thank you so much. So I want to take just a moment to thank the fine organizations that make our work possible here at the Passive House Accelerator. So a big thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. And thanks too to our champion sponsors, Bewizo, Icon windows and doors, intelligent membranes, pH air seal, and Source 2050. And a big thank you to our patron sponsors as well. Brennan, Holstrom System, Innotech Windows and Doors, Lamilux, Longboard, RDH Building Science, and Sanderson Sustainable Design. Thank you, sponsors.
Awesome. Thank you, you two. And thank you, sponsors. We love you. All right, guys, we're going to go ahead and jump into the question and answer segment. I'm just going to give a quick reminder of how we do things here. We have a queue. Kim has posted it in the chat. Jose and I will kind of call out your names. If you're still on the call and you would like to unmute and ask your question, please do. If not, we will go ahead and ask it for you. So let's get started. I have Graham first, and your question may have been answered a little bit in the chat about the construction with the meters squared, but if you'd like to ask again or give a little bit of commentary, feel free to do so.
Sure. First, I want to thank Elisabeth for this amazing presentation and give a shout out. I already went to her website and there are a bunch of really cool reports there. So get those.
Thank you.
I just looked at those stats and I don't even remember how many New York cities there was a New York City being built every 20 minutes or some crazy number like that. I was like, where is this possibly happening? And then Zach answered with a reference to a map, and it looked like most of it was in, I guess, Africa and Asia, but it looked like there were like 2 twin mega cities coming up in the west part of Texas down by the Gulf Coast. But again, I was just sort of shocked at that statistic in terms of where would we even fit that stuff. Certainly, a lot of the US is pretty anti-growth, and I can't see New York City every 20 minutes happening in a lot of spots, but I don't know.
Thanks, Zach, for sharing that map. Actually, I hadn't seen this one before, and it's November 2023, so like pretty recent too. So I'll keep this one for the future reference too. Thank you.
You bet.
All right. Thank you for the question. Thank you for the comment, Elisabeth. And up next, it's actually Zach.
Yeah, Elisabeth, I think you addressed a lot of this already, but maybe so I think that LCA analysis and embodied carbon analysis, I think, can feel maybe a little daunting for the solar practitioner or small firm. It's like, oh, okay, another set of things that we need to be understanding and analyzing and folding into our work. So I guess it's a two-part question. One is, what's an easy way to get started on that analysis? But two, are there kind of easy, a set of key moves that people can make without analysis that can make a big dent in the embodied carbon impacts of their projects?
Yes, sure. First, yes, there are some tools that, and Chris Magwood's tool from Builders for Climate Action, the BEAM tool, BEAM, is one of those tools that is free. They do training regularly, and it's fairly easy. Like, it's a spreadsheet-based tool that we use for very preliminary LCA when we are at the very early design phase where we want to compare different materials. So this tool is very easy to use for comparing 2 different sets of materials right early on in the design. Super easy. And yes, without doing this, just thinking, what are the 3 things? Again, concrete, number 1. Can you reduce the concrete? Talk to structural. Some of the very progressive structural engineers will help you reduce concrete. There are solutions, and I'm not a structural engineer, I can't speak about that, but there are solutions. And reducing concrete, looking at insulation materials, is there a one-on-one replacement? Wood fiber insulation is available on the East Coast through Timber HP, not yet on the West Coast. I just can't wait for it to be available here, but there are low carbon materials that are just a one-on-one replacement in the insulation space, which is easier, I guess, as a first step. And thinking about, let's think about windows, because those are also a big can have a big impact. So sometimes, you know, making good use of windows in the right places, right location, orientation, making sure that you know, like the floor to ceiling window, I think is really hard for energy efficiency as well as embodied carbon. So looking at, you know, being smarter about window location sizes.
Fantastic, thank you. That, and you started with that the beam tool, and I asked a similar question recently of Chris Magwood, and he made the same point that you just made, which is that you don't necessarily need to model an entire project to get a lot of good information from the beam tool, because you can be you can just like do, you know, model a 100 square foot, you know, assembly or whatever, and put in a couple of different options for materials and look at the comparison. So it can help you make material by material decisions that you know that's at least going in the right direction.
Yeah, exactly. Yeah. And that's a free tool, so also very easy to use. So
yeah, thanks.
Okay, let's see who is next. I have Jose. You're next. This is fun. It's like that Spider-Man meme where we're all pointing at each other.
Yeah, pointing the finger, the next one. Yeah, thank you, Lisa, for the presentation. I mean, I found it really really interesting. It also gave me a lot of good ideas. I mean, I haven't been doing a lot in the embodied carbon field, but it's something that I've been really looking forward to learning more about. So, I mean, mine was more of a kind of like a 101 question. Like, do you know if if you or someone has any documents or guides available for practitioners or homeowners that are trying to get into this planning stage that is not too technical and kind of difficult to follow, because sometimes you get like one of the slides you showed was kind of like one of these ingredients chart, and that just gets a little overwhelming, especially if you're looking into designing a building.
yeah,
So I just wonder if there's anything that in terms of like what can I use to substitute, or what are like easy things that I can do and how to do them to actually get excited and find it easy to get into the project design or construction, I guess.
Yeah, I just popped in the chat the link to the City of Nelson a website, and they just launched literally like a week ago some one-pagers for either energy advisors, architects, engineers, designers, building officials, and homeowners, with the content slightly adapted for those audiences. And I found them absolutely wonderful because super, visual, easy to understand. And again, tackling those first three things that you can do that have a big impact. So I encourage everybody to check them out.
Yeah, no, that's great. I just clicked on it, and it's something I'm gonna definitely check out after the call presentation. And after me, there is Jean Di Giovannis. If you're online, you can ask your call.
Yes, I was
Ask your
curious
question.
about some low carbon options for foundation walls. And what occurred to me was perhaps wood foundations. And have you had any experience with that durability? That would probably eliminate the need for exterior insulation, since it is not such a capillary wick and as concrete would be, and you can pack a lot of insulation on the interior.
Yes, we don't have direct experience with bio-based materials for basements or foundations. Besides, so we are using on a project pier foundation, so that eliminates a lot of the concrete, and then you can do wood and different types of bio-based materials. I heard that in Germany they are using a lot of wood foundations as well, with years and years of experience leading to like, yeah, it actually works. We haven't seen one project here that doesn't have concrete at all whatsoever. But the city of Vancouver is actually removing their, they are not going to be allowing basements anymore for this very reason of using less concrete. So looking ahead, I think we'll see a lot less basements, and for foundations, we'll see some options around, pier foundation, maybe concrete-free foundations where it makes sense, and in different climates as well. So,
are you aware of any low carbon concrete blocks, perhaps with insulation in them?
So do you mean like the ICF?
No, I mean a concrete masonry unit.
No, I'm not personally. Maybe that's a topic for Friday. Maybe there'll be options on Friday for low carbon concrete options. We haven't seen anything like this here.
Thank you.
Oh, there we go. Alrighty, it looks like our next question is from Mario, but I am going to go ahead and ask for him. How quickly is the integration of more natural products being recognized, certified, adopted, or utilized in the BC Building Code? And this is a two-part question, so that's part one. Part two, how are you finding or dealing with fire concerns with commercial and residential and the incorporation of more natural products? So maybe fire resistance and resilience. With commercial buildings, obviously kind of having some higher fire standards.
Yes. So the first part, the province of BC has been looking at wood fiber. Like, I worked on a market analysis for wood fiber insulation in BC. That was a year and a half ago. It is part of the building code, and I'm not a code consultant, but so far there are some limitations on what materials can be used. But also they all fall back to the certifications. So as long as a material is certified for fire rating and there is the certification, then it's good to go. Fun fact that actually wood fiber, it looks like I'm advertising for wood fiber. I just really like wood fiber because it checks a lot of the boxes actually.
It's cool.
It's pretty cool. Is actually extremely fire resistant. So it's counterintuitive, but some of the petroleum-based materials actually just burn faster. So, and are more toxic when they burn as well. So lots to do in the bio-based field for sure, and lots more to come, I hope. I've heard of some new innovative materials coming up, and I can't wait for them to get all of their certifications, all of the, the stamps on the materials so they can start manufacturing and selling them. I feel like this is, in the next 2 to 3 years, definitely a lot more on the market.
Totally. Yeah, I agree. There's some really cool stuff, and you're kind of right. Some of the more counterintuitive things actually are pretty good with the fireproofing. I know we have at Small Planet Supply some thermocork, and it's like a cork insulation, and you can use it for exterior or interior insulation, and it is so good with the fire, very high fire tolerance. So that's not something, people think like the wood fiber and the hemp and the cork and whatnot, and they're like, no, what exactly will catch on fire? Those things.
Love cork as well. I haven't seen it in projects, but yeah, just the fact of like it's very resource efficient the way like cork is made. So,
and it's beautiful. It looks really good.
Yeah.
All right, Jose, I'll hand it over to you.
Thanks, Sarah. So last question for the session. It's from Michael Bartko, but I think he's left the meeting. So I'll ask it for him. And then I have just one follow-up question after that one, just to finish it off. So his question is, does window frames, vinyl versus wood, make a difference in embodied carbon? And was it considered? I guess it's referring to your project, the one that you showed.
Yeah. So yes to both questions. Definitely wood better in terms of embodied carbon purely than vinyl. However, vinyl is also more durable. So there's again that balance about, you know, how many, like when are you going to be replacing those windows? Is vinyl a lot longer, a bit longer, depending on the manufacturer? That was a consideration for the project. So we went ahead with all wood for this project.
Yeah, that's a question I get sometimes actually. What's better, wood or vinyl or PVC? And it's all about the durability and what you're intending to do and where it's going to be.
Yeah.
But I guess tying into that question, I just had kind of a comment or question just for discussion. Maybe it's part of the AMA on Friday. So what approaches have you seen or do you have, I guess, to promote and sell low embodied carbon projects? Or do you actively look for clients? They look for you, or you work with the architect? Like, how do you get to build one of these projects? Like, do you go around, or or you wait for someone to come, or you just try to spread the word and hope that somebody falls, and then you can try to push it over and get a good project going?
A bit of both, I guess. I think a lot of people come to us because they know we are looking at high performance buildings, but a step further. So we have some clients that come to us for that. In terms of for the Phoenix house, I was introduced by the architect to the builder. And then we really hit it off. So we had that very first integrated design meeting with the homeowners. Like usually we don't always meet the homeowners actually at all, or we meet the homeowners much later in the process. And in what makes these projects so special is that we connected with the homeowners at the very beginning, first meeting with the whole team. So the builder, the architect, the site supervisor, the homeowners, and us. And we sat for 3 hours, really looking about this project, what that means. Okay, you want a low carbon. So I started with the obvious, which is let's go all electric, super high performance, energy efficient, all of that. And then I could see that they were like, okay, yeah, that's great. Let's do that. Let's do all of that. And then they were like, okay, what's next? And I felt like I could keep going down the list of things that, you know, we want to see on projects. And they were just very receptive. We're like, yeah, this is the right thing to do. And we're going to make that happen. And for sure, not all clients are like this, but that's the whole reason why we are also documenting this. And they are fantastic homeowners, fantastic people, and they want to showcase that this is doable now from their perspective, also as homeowners. So I'm hoping that from this project, you know, a lot more people get convinced on the general public that, you know, this is the right thing to do. It's not hard, and you got to put the right team together.
Yeah, no, that's right. So basically, we should definitely stay in touch with you so that we can learn a little bit and then get our clients to go the right way and do the right project.
Anytime. And I'm always, that's the thing is sometimes, you know, if we're not hired by the homeowners directly, which doesn't always happen. So we could be hired by the builder or the architect. And sometimes they are not comfortable having this conversation with the homeowners necessarily, or they don't necessarily obviously know as much that this is our field, right? But I'm always happy to go and meet with the homeowners or have those conversations. That's the thing, is like, I want to promote building better in general, and that means different things for different people, but I'm always happy to go and meet with the clients anytime. And when I say that, some builders are like, oh, that's great, yeah, I'll bring you over to the next meeting so you can explain all of that, because I have no idea how to explain it. And I'm like, no problem, I can explain that, no problem.
Yeah, no, that's great. I mean, I'm glad to hear that. And yeah, I mean, thank you so much for your time. I think we're done with the questions.
Yeah, thanks so much, Elisabeth. It was really amazing. Really appreciate it.
No, thank you so much.